Hello everyone, I'm Joe Johnson, Joe the math teacher. I've been doing videos for my online classes for 10 years or more. I have several hundred videos, but this is the first video I've made specifically for teaching math, primarily for teachers and for parents. I really want to focus in on teaching elementary math, basically math from the beginning through algebra, statistics. Statistics is really important because we live in a world where people want to make database decisions, and so a basic knowledge of statistics really is important. Math is super important because if you're going to make, design, plan, do things, there is math involved. If you're at a job and you're not doing math, it just means you're not making decisions, because in those things, making, designing, planning, there is math, and a lot of it is algebra. If you're designing things like being an engineer, you're getting into calculus and definitely into statistics, because a lot of the times in the statistics we're getting to the point where some of the super high-tech statistics is such that you can run fewer experiments and get to the final results much quicker. And yes, it does get pretty important when you get into the nitty-gritty up there. Okay, back to the point. I really want to focus in on elementary math, getting things right from the beginning. Elementary math is concrete. It is not abstract in the math itself. We have had to create language to express, to communicate what the math is going on. For example, the Arabic numeral 3 is not the same as the number of fingers I'm holding up. However, we use that to represent this in an abstract way. Math is not something created. Math is something that is discovered. And so we need to keep that in mind as we go forward. I see rigor in math as teaching for an understanding, not just so things can be calculated, even calculated correctly. Caring and borrowing are great examples. I mean, when I started out teaching math back in my undergrad days, I studied communications math and education. I did teach math at that point. I did tutor statistics. I was pretty good, but the thing is, discovering what it really took to make people understand what is going on is really important. For example, carrying and borrowing. I've heard borrowing described as redistribution. That would be from Ma Li Ping, who wrote an incredible book on teaching elementary math in the United States, and I do highly recommend that. It is really important, not just so that the kids go and that's 1,000 minus 999, that they just don't go cross everything out and go 0, 9, 9, 10, and really not have an idea that what's going on is that you're redistributing that total of 1,000, but you're not changing that total. They need to understand where every last numeral, every last number count in there is going, and that at the end of it all, that 990 plus 10 is the same as 1,000. And just show them where things are redistributed to make sure that they actually understand. It really makes a difference, because as you keep going up through math, if the kids, the students, don't have that complete understanding of what's going on, they will get lost. So I really emphasize on that understanding. The other thing is teach the math and keep them going. Momentum is a very, very important thing. Summers off for students is really bad because they tend to slip back, maybe 2-3 months, maybe more. Giving them something over that time to keep them going, again, that's where the parents come in, helping them out, and again, understanding that math. One thing, this is maybe beyond elementary, one of my kids was in math counts, and one of the things they looked at was modular math. And kid comes out and says, "Oh, what were you looking at?" Modular math. I said, "Oh, what is that?" And I got a perfect textbook example where you take the the final number, and you divide it by the modulo, and the remainder is the answer. It was correct. Now the thing is, I just described it, and many of you are still scratching your heads. Okay, what does that mean? Well, the thing is, I'll give you a real concrete example. 23 in modulo 7 is 2, because 7 times 3 is 21. 23 minus 21 is 2. In more concrete terms, and this is where we start getting into an understanding, is in 23 days what day of the week it is. Well, it's going to be 2 days more than what it is now. A lot of things in nature and a lot of things we do are cyclical, and that's where modular math comes in. And in fact, the security on the chip on your credit card is modular math. Looking at time, we can either say we have 12-hour circuits twice a day. We have 24-hour cycles if you want to go that way. 12-month cycle for an entire year. So if I ask you in 20 months, what month will it be? You should be able to figure that out. That's modular math. But actually getting into what it is and creating that understanding is where it is at. The other thing is to keep going. One of the things is another math teacher told me, for example, girls do great in math, but then all of a sudden they turn teenagers, then they sort of slow down, they lose interest in math. The thing is, build them up as much as possible in the earlier years so that they're further ahead when they reach teenage years, and it will actually help them advance better once they reach that. So these are the kinds of things I want to go through, make math real, and even possibly make it exciting. Hope you all enjoy this, and hope you come back to look at more. I also hope that there will be a lot more, and please hit the subscribe button. Thanks.